As nitrogen is expensive, it is practical to use inert gas produced through stoichiometric combustion on board in the inert gas generator. Furthermore, this plant can generate dry air too. Inert gas is generated by burning low sulfur fuel under controlled circumstances and subsequently cleaning and drying the exhaust gases. Inert gas used in LNG carriers should be of high purity. Oxygen levels of 0.5% or even 0.1% are required, in combination with a water dew point of about -45 degrees centigrade and sometimes as low as -65 degrees centigrade. It should be low in carbon dioxide content and should be soot-free too, as they can clog the system under cryogenic conditions. When the gas leaves the generator, it has the right composition, but it is saturated with 100% water and has to be dried. It is first dried in a refrigeration-type dryer, followed by a regenerative dryer to get the required humidity levels. We can produce dry air instead of inert gas with the same capacity. There is no combustion in generator and only the dryer is used. Dew point is measured, but oxygen content signal is overridden. After the processes of cooling and drying, and if the dew point is correct, the compressed air is supplied to the cargo system. Rating: 15,000 cubic meter per hour at a discharge pressure of 1.3 bar absolute. Fuel consumption 1,400 kilogram per hour. Combustion air 9,900 cubic meter per hour at 700 millibar discharge pressure. Location: main deck level in the engine casing. The main and pilot burners are mounted on the combustion chamber. The combustion chamber is surrounded by a cooling water jacket to dissipate the generator heat as much as possible. The cooling water jacket is provided with a spiral to make sure that cooling water flows around the combustion chamber wall, thus achieving optimal cooling effect. Gas oil is supplied at a constant pressure by the gas oil electric pump, which has a built-in pressure overflow valve. The fuel oil flows to the nozzle of the main burner via a pair of solenoid valves and regulating valves. A program switch in the local control panel regulates one of the solenoid valves, the pilot burner, and initial firing. The inert gas coming from the burner has a rather high temperature and contains sulfur oxides. In this section, the construction ensures an intense contact between gas and water, reducing the inert gas temperature and the content of sulfur oxides. Water droplets are separated by means of a demister before the gas leaves the generator. The combustion process guarantees that absolutely no soot will be produced. Not even at under stoichiometric conditions such as insufficient air supply due to a drop in blower speeds following an electric supply fluctuation. The combustion air is supplied to the main burner by two Roots-type blowers of 50% capacity each. The quantity of combustion air to the burner can be manually adjusted by a regulating valve in the excess air discharge line. The water seal mounted under the cooling section of generator unit discharges the cooling water and condensate from the generator, whilst at the same time maintaining the required overpressure in the generator and avoiding the escape of gas or air. The height of the water seal is designed so as to ensure a constant and stable pressure in the combustion chamber. A level switch controls the discharge of water from the generator. It works in series with one of the seawater ballast pumps, discharging to three directions. A. Directly to a sprayer at the outlet of the combustion chamber. B. To the sprayer pipes in the cooling or scrubbing tower via one orifice plate. C. To the cooling water jacket of the combustion chamber via two orifice plates. The seawater leaving the sprayers flows out via a water seal, and the cooling water leaving the jacket is discharged directly overboard. In this equipment, the inert gas is dehumidified to the required final dew point. A desiccant, adsorbing the water still contained in the inert gas, now effects drying. The inert gas dryer has two vessels. While one vessel is in drying operation, the second vessel is being regenerated. The electric heater controls the temperature of the regeneration air. The hot air goes in counter now through the vessel that has just finished the adsorption period and been depressurized. The refrigerating unit functions to cool down the gas to a dew point of up to +4 degrees centigrade. Most of the moisture and water content present in the gas is removed in this unit. The oxygen content must be below 1% volume and the dew point up to a maximum of -65 degrees centigrade with a minimum of -55 degrees centigrade. Both parameters are displayed locally and remotely. For delivery of inert gas to the cargo system, two combined remote air-operated control valves operated through solenoid valves are fitted on the distribution system, that is, the purge valve and the delivery valve. Located at the outlet of the dryer unit, it maintains a constant pressure throughout the system, thus ensuring a stable flame at the generator. For delivery of inert gas to the cargo system, two combined remote air-operated control valves operated through solenoid valves are fitted on the distribution system, that is, the purge valve and the delivery valve. A good combustion is essential to the production of good quality, soot-free low-oxygen inert gas. The products of the combustion are mainly carbon dioxide, water and small quantities of oxygen, carbon monoxide, sulfur oxides and hydrogen. The nitrogen content is generally unchanged during the combustion process, and the inert gas produced consists mainly of 85% nitrogen and 15% carbon dioxide. Initially, the hot combustion gases produced are cooled indirectly in the combustion chamber by a seawater jacket. Therefore, cooling of the gases mainly occurs in the scrubber section of the generator, where the sulfur oxides are also washed out. The seawater for all the inert gas generator needs is supplied by the inert gas booster pump, working in series with one of the seawater ballast pumps. Before delivery out of the generator, water droplets and trapped moisture are separated from the inert gases by a demister. Further, removal of water occurs in the refrigerating unit, where the gas is cooled to a temperature of about 5 degrees centigrade. The bulk of the water in the gas condenses and is drained. In the final stage, the water is removed by absorption process in a dual-vessel desiccant dryer. A pressure control valve located at the outlet of the dryer unit maintains a constant pressure throughout the system, thus ensuring a stable flame at the generator. Dew point and oxygen content of the inert gas produced are permanently monitored. The oxygen level controls the ratio of the air and fuel mixture supplied to the burner. The oxygen content must be below 1% volume and the dew point up to a maximum of -65 degrees centigrade, with a minimum of -55 degrees centigrade. Both parameters are displayed locally and remotely. For delivery of inert gas to the cargo system, two combined remote air-operated control valves, operated through solenoid valves, are fitted on the distribution system, that is, the purge valve and the delivery valve.